And so what I did is I took the formula for cylinder. So you have base, which is pi r squared. That's 16 pi times height. So 16 pi times h. So there's your formula for the volume is 16 pi h. And I did the volume of a cylinder, 16 pi times h, equals the volume that they gave you for the cylinder, which is 112 pi. And so to make things a little bit easier on myself, I canceled out the pi's. And then I got 16 times h equals 112. And then I just divided each side by 16 to isolate the h. Got a height of 7. For 18, to find the volume of half a sphere, you just take the formula for a sphere, which is 4/3 pi r cubed, and you just stick a 1/2 in front of it. And then they told you that had a radius of 5, so I just did the normal sphere formula. So 4/3 pi times 5 cubed, but with the 1/2 in front of it. And so then got 250 divided by 3 pi. The last one was really similar to that example problem. The only difference was that you had to do it kind of in terms of pi. So if you kind of take 19 and then compare it to this problem. So here was the example problem you had. It looks very similar. See that? They're very similar problems. The only difference is this one, since it was a pyramid, it didn't have any pi's in it. And then this one, since it was a cone, it did have pi's in it. So when you did 19, you still were going to do the big one minus the small one, just like we did in the notes, the big pyramid minus the small pyramid. The only difference is that when you do 19, you can kind of see the answers are in terms of pi. And so when you do your answers over here, you leave them in terms of pi as you do them. So don't write out the whole thing as just decimals. Don't multiply the pi into the number. You can multiply the coefficients of the pi out to get decimals. And this is like a pet peeve of mine. I hate when people do this, and not normal students, but I hate when mathematicians do this because it's like doing an inexact answer, like an approximate answer and an exact answer all in one. So they approximated the coefficient of an exact answer, which is, I don't know, it's like somebody doing a nickname of a government name. I don't know. It's like a contradiction in terms, I guess. I don't like that. But that's what they did. So they did the volume of the overall cone. So you're taking this radius down here to find the area of your base, and then multiplying it by h1 to find your height. So 1/3 times that base times that height. So here's your volume of the big cone. And then you're finding the little cone right there with the R2 and the H2. And then you're just subtracting them, big cone minus little cone. You're just leaving the pi in there instead of multiplying it all out. But it's just like that second example, just cones instead of pyramids. Yeah. Okay. All right, how do we feel about finding volumes? 30%? Yeah, so the reason I gave you guys formulas in kind of a general sense instead of like giving you like 15 to memorize is because you do have to have them memorized. So that's why basically the way that I narrowed it down is so it's kind of like there's 3 formulas. So the 3 formulas we had is for shapes that are perfectly up and down. This is area of base times the height. For shapes that taper in, it's 1/3 area of the base times the height. And then for a sphere, it's 4/3 pi r cubed. So that there's only 3 formulas to memorize. That's kind of the idea. So that if you can look at a shape and know the area of the base, because most of the areas of the bases are formulas you guys already know. Like if the area of the base is a rectangle, you guys are like, oh, that's length times width. If the area of the base is a circle, then you go, oh, that's pi r squared. Hopefully we know that. That might be the shaky one. If the area of the base is a triangle, you go, oh, that's 1/2 base times height. So hopefully when you see the base area, you kind of know that. And then all you have to do is go, oh, is the shape straight up and down? Is it like a log kind of shape where it's like consistent? Or is it something that kind of tapers in? And if it does, then it's got a 1/3 in front of it. If it doesn't, then it's just base times height. So that was kind of the idea, is that if we can narrow down our formulas, then you can kind of recognize either it's base times the area of the base times the height or 1/3 times the area of the base times the height. And you guys already know the areas of the bases. Or it's a sphere, which is 4/3 pi r cubed. That was kind of the idea of yesterday. Okay. Now, the nice thing about today is we're actually going to like reaffirm those notes. So today, if you guys watched the notes last night, they were easy peasy, right? Like we were essentially thinking of our 3D shapes as like a piece of bread, you know, like a hunk of bread, and we're taking a slice of it and we're saying, what is the shape of that slice? That's essentially what we were doing. Today has 2 concepts. So we were taking those notes last night. We're going to do an assignment for that. And then that's supposed to be quick. That's supposed to be beginning of class quick. Then we move on. Then we do another set of notes. And then we do another assignment. So today is a double day. Okay? Because the notes last night were not meant to be difficult notes. They were meant to be pretty easy. Okay? So let's open up those notes. There's one thing I want you guys to add at the bottom. Yes. Yes.
I think you explained how it was a rectangle.
Uh-huh.
I was kind of confused because so is it talking about like the face of it? Like when you cut it, you flip it, like the face of it?
Because if you look right here, this corner right here would be a 90-degree angle.
Mm-hmm.
And so if you have a 90-degree angle there, that's not a circle anymore. That's making another shape. So if you have a 90-degree angle here, on this other side, you have a 90-degree angle there, then you have a 90-degree angle here, you have a 90-degree angle on the other side. We've made 4 90-degree angles. Now we're talking either about a square or a rectangle. Does that make sense? And so then, if you're trying to figure out which one it is, I can see that this side is pretty long, and then, Keld, I can see this side is a little bit shorter, and that's what makes it so it's a rectangle, not a square. So it means that depending on which way you slice it, if you slice it perpendicular or if you slice it we would call this like horizontally, or you'd call it parallel to the base, then it's going to make a difference. Parallel to the base would be different than if you're perpendicular to the base. So one thing I want you guys to write down here at the very bottom of your notes is, if the slice is parallel to the base, then the resulting cross-section is the same shape as the base. And you guys kind of know this because of how like cookie dough works. Have you guys ever had like the tubes of cookie dough and then you like slice out the tubes, right? You like just slice the tubes and it makes the cookies and they're all circles? Anybody? Or if you wanted to like, if you were doing icing, you would have like the little, you'd like squeeze it out of a tube that's that shape, and then you could cut it and make like little slivers of that shape of something. So you kind of have seen this in the past, this idea. But if you are cutting something that's parallel to the base, then that resulting cross-section is the same shape as the base. And that's a nice little trick where you don't have to mentally picture the 3D cross-section. If they say that the cross-section is parallel to the base, then you go, oh, what shape is the base? Because now I know. If they say, oh, this is a triangular prism, and we're cutting the cross-section parallel to the base, then you go, oh, it's a triangular cross-section. If it's an octagonal pyramid, and you're cutting it parallel to the base to find the cross-section, then the cross-section is an octagon. If it's a cone, and you're cutting it parallel to the base, then that cross-section is a circle, because cones have circles as their bases. So as soon as they tell you that they're cutting it parallel to the base, whatever that base shape is, you automatically know that's what that cross-section is. So it's a nice little hint. These are kind of gimme questions if you can recognize this. So these in the wording, you're going to look for that wording. Anytime it says parallel to the base, those are questions. As soon as they say that, you go, oh, I know what the cross-section is. I don't even have to think about it or look at the picture. I already know. And then some other ones, you're going to have to look at the picture to figure it out. All right. So for today's assignment, if you did not print it, then you can look. You can look up here, so you can see we have 3 different things we're doing today. You can look at the first one. This one, you do not have to draw pictures. If you're doing it on notebook paper, you just have to write down the multiple choice answer. So this entire assignment is multiple choice. So here they said we have a trash can. The bottom portion of the trash can, so not the lid, not the part you're putting trash in, but the bottom part, the receptacle part that's holding the trash, is a rectangular prism. So they're talking about this part down here. Can you see my mouse? Is it too light? So this part right here, this is the bottom part, okay? So they're saying the bottom part is a rectangular prism. They're calling it a rectangular prism, so what shape is the base? A rectangle. Okay, the base is a rectangle. If the trash can is sliced horizontally, if it's sliced horizontally, is that parallel to the base if you're slicing it horizontally? Yes. Okay, so what shape is the cross-section? A rectangle, so what answer choice is correct? Z, that's a rectangle. And so the answer is C, which is Z. I do not know why they didn't just use W, X, Y, Z as their multiple choice letters, but they decided to do A, B, C. For whatever reason. I did not make up the letters of this worksheet. Somebody else did, and they were silly. So they have the trash can, which is a rectangular prism. That means that the base shape is a rectangle. Then they told you to cut it horizontally, which means you're cutting it parallel to the base. And so since you are cutting it horizontally, you're cutting it parallel to the base, that means that the shape has to be a rectangle, which means that the shape has to either be W or Z. W would be if they were cutting it perpendicular to the base. Z is if they're cutting it parallel to the base. Does that make sense? Okay, so we chose our answer there. Number 2, a cube is sliced diagonally containing 2 vertices and perpendicular to the base as shown below. Which figure best represents the cross-section parallel to the slice? So they showed you the slice. Can you guys picture what shape that would have made? So you're picturing a slice of bread. We're not picturing something 3 dimensions. We're picturing something 2 dimensions. So you're picturing, yeah, what the slice would have been. What would it have been? Yes, a rectangle. It would have been a rectangle. All right. And the reason you can kind of tell is because you've got a corner, 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 and we can imagine a little corner back there. So if I've got something that's got 4 corners, then it's going to have to be a shape that has 4 corners. So we cut out, it definitely is not a square, definitely is not a triangle. It's going to have to be either a trapezoid or a rectangle. All right? Okay. A display cabinet, the display area, so this is the display area. They said this is a rectangular prism. So again, they're telling us that the base has a shape that's a rectangle. They are slicing it horizontally, and which image best represents the cross-section that is parallel to the slice? So they're slicing it horizontally, not vertically, horizontally. So it is Z again. So that question was almost identical to the trash can question. A cone is sliced vertically through the vertex with a plane perpendicular to the base. So we can't use what we know about bases this time because the cross-section goes the opposite way. Which figure best represents the cross-section parallel to the slice? We got a cone this time, not parallel to the base this time. Triangle. Looks like a triangle. All right, this one, it's an octagonal pyramid. They're slicing it horizontally. So it is being sliced parallel to the base. So what's the slice? X. It's going to be an octagon. Yeah. Yeah. All right, so go ahead, go through. That's fine. So go ahead and go through and just pick the multiple choice answers. If you did not print this out, that's fine. You're just writing your answers on a separate sheet of paper. You do not need to write the questions. All right? And then when you are through with this, we will take our notes for our second portion of the class. So the composite figures are figures that are made up of more than one shape. So for example, 1, we have 2 shapes that are being added together. You have a bottom shape, you have a top shape. You're going to add them together to get your composite shape. For example, 2, we have 2 shapes that are being subtracted. So this is supposed to be a triangular prism with a cylinder hole, a cylinder-shaped hole in the middle where it's like something's being taken out of it. So this is where you're adding 2 shapes together. This would be where you're subtracting 2 shapes from each other. So composite solids are just solids where there's more than one shape working together. The nice thing about this part of the assignment is we're just going to be taking what you did yesterday and we're going to be doing it again, but for each problem you're going to use 2 volume formulas instead of 1. Okay? That's the only difference between yesterday and right now. So what are the 2 shapes that we have here on top and on bottom? What are they called? Rectangular prisms, both of them. Okay? Do you guys want to think of the base being the 2 by 6, or do you want to think of it being the like 2 by 1? 2 by 6? Okay, so I'm going to say the bottom shape and I'm going to say the base of the bottom is 2 by 6. So the area of the base is 12 feet squared. So like I said, we're going to have really good notes. And then if you want to show less information when you do the homework assignment or the practice assignment, that's fine. So right now I'm saying, okay, the bottom rectangular prism has a base of a 2 by 6, and that's 12 feet. Okay? And then it has a volume of area of the base times the height. And 12 times 1 is what? 12 feet cubed. Okay, so there's the volume for the bottom shape, 3D figure, okay? And then what is the base of the top gonna be? It's gonna be 2 by 4. And so what is that area? Yeah. How did we know it was 2 by 4?
Well, no, so I see that the 4 is there, but isn't that for like the top rectangular prism and not
It's 4 right here, so it's still 4 right here, so it's still 4 right here. And then this was 2, so it's 2, 2, 2. So then we said, okay, this base is 2 by 4.
Because I was like, the bottom one goes farther than just the 4 feet.
Yeah, yeah, so we had just done the 2 by 6. We just did the bottom one. Now we're doing the top. You're good. So 2 by 4 is 8 feet squared, okay? And then our volume is going to be area of the base times the height. And what's the height of this rectangular prism? 0.5. And then what is 8 times 0.5? 4 feet cubed. Okay? So then for our total, we're going to take the bottom, we're going to take the top, we're going to add them together. So we're going to say 12 plus 4 is 16 feet cubed. And that is the volume for our composite figure. All right, and Madison and Annika, I'm gonna have you guys go back to your table. Schenkel. Okay. For the subtraction ones, I usually think of like the outside shape versus the inside shape. So what is the outside shape? So when we do the composite figure, we're trying to overall find like what the combined, or maybe if you're supposed to subtract something. So this, we were trying to find the combined volume. Here, the idea with something like this is that that cylinder inside is hollow. And so we want to take the, oh, it's hollow. That's the idea here. And so what we want to do here is take the overall shape and take out that hollow piece. So this would be like a subtraction problem instead of an addition problem. So we're going to do the outside piece, take away the inside piece, and that's going to be our composite figure. All right, so what is the shape of the outside piece? Triangular prism. So the base, the area of the base is going to be the area of the triangle. So I'm going to do 1/2 times the base of the triangle times the height of the triangle. So what's the base of the triangle? What's the height of the triangle? Okay, so 1/2 times 6 times 5 is 15. Okay, and then the volume. So how do we find the volume of a triangular prism? Times the height. So this is going to be, you had the right idea with the width because it's laying on its side, right? That's why you were thinking width, is because it's laying on its side. So this is a triangular prism is one of those prisms where it's kind of like a log idea. It's not tapering in. It's the same all the way across. It's like a loaf of bread that's just a triangle shape. Yeah.
So I was like thinking about this earlier. I was thinking, what if a triangle is like half of what the like square would be? Like the whole or cube would be. If you just took the base times the height times the length, and then divided it by 2, would you get the volume of the?
The half that you're talking about is why there's a half right here. That's why there's a half right there. So you're already taking that into account.
Like if you multiply 6 times 5 times 4, you get the volume of that cube. And then if you have that, then you get the volume of the. Okay, but we got the base. Okay, I was just
Yep. So now we're going to say area of the base, which is 15, times the height of the prism, which is 4. So even though this prism, it's kind of like the idea is the prism is laying on its side. That's the idea of the prism. So it has a height of 4, and it's just laying down. So 15 times 4 is what? 60 feet cubed, okay? So the volume of the outside 3D shape is 60, and then what's the shape for the inside? Cylinder. Now, they have this little line, and the line goes all the way across, and so they're telling you that it's 2 feet, but is it a radius or is it a diameter? It's a diameter that's 2 feet because they're giving it to you all the way across. Does that make sense? It's an arrow pointing, but in this case, since the line goes all the way across, they mean that it's a diameter. Yeah. So the diameter is 2 feet, and so what is the radius? The radius is 1. Okay, so let's find the base area of that cylinder. So what's the base? Pi r squared, and so pi 1 squared is just pi. And then how do we find the volume of a cylinder? Yeah, area of the base times the height. So the area of the base is pi. The height of the cylinder is 4 times 4, so that's 4 pi. Okay? And then to find the overall shape, what are we going to do? Subtract them, outside minus inside. So we're going to do 60 minus 4 pi. And then here, when we do this, we're going to get the decimal answer because 60 minus 4 pi doesn't mean a whole lot to us. So we're going to say this is approximately 47.434 feet cubed. All right, how do your brains feel? Okay. Kind of confused, but kind of okay. Okay. All right, now we've got another shape here. So we've got a door. They said we have a wooden gate where each of the 6 boards make up the lower part of the gate, and they're the same size. And then the top piece is a semicircle, and it's a piece of wood. So they said X is 6 inches, Y is 4 inches, Z is 36 inches. Okay. So we could start with those. Each of these wooden pieces, if we just consider one of them at a time, what shape are these? They're rectangular prisms, right? The bottom is a 6x4, so that's a rectangular shape. And then they go straight up and down. They don't taper in, so they're rectangular prisms. Okay. So I'm gonna say one board. We've got one board. Okay. How do we find the area of the base of one board? The area of the base of one board. 6 times 4, so we'll do 6x4. Length times width. Okay. So 6 times 4 is 4, okay. And then the volume is the area of the base times the height. Okay, so one board has a volume of 64. Okay, and then how many of those boards are there? Okay. So we need to do 864 times 6. Okay, so what's the volume of the entire bottom part? Okay. What is the top part most similar to? You heard it. It's like a cylinder almost, but not quite, right? It's a semi-cylinder? It's half of a cylinder. A cylinder cut in half. Semi-cylinder. Okay. So we got the board. Let's go ahead and work at the top. Okay. So how do we find the area of the base of the top? Because a cylinder would usually be the area of the circle times the height. Okay, so we're going to do 1/2 times the area of a circle. Okay. So 1/2, and then it's going to be pi r squared. Can you guys tell what the radius of that top part should be? Yeah, Madison. Because we got, so this is the diameter of the circles, the whole thing. Yeah. Uh-huh. 18, 6, 6, 6, so that's 18, okay? So we're going to do, for the area of the base, we're going to do 1/2 pi times 18 squared. Okay, so let's figure out what that is. What's the area of the base? Yeah, we'll just stick out the pi on the end. Yeah. Anyone know? Who has fast calculator fingers? 162 pi. Okay. And then this is not a very tall cylinder then, because the height is just this part. So now we're going to do area of the base times the height for the volume. So area of the base, 162 pi, times the height. And then what's the height? 4. So the height happens to be the width of the door for how we're calculating this. So what is the volume? 648 pi. Okay. Inches cubed. So that's the top of the door. Okay. So if we wanted the total door, what do we do? Do we subtract them or add them? Add. I got a number that starts with 7. Did you put the pi on there? Did you put a pi on here? Yeah, I got a 7. So when you type it in, it should look like this. Okay. So 7,219.752 inches cubed. Cool. Wow, what an interesting problem. All right, I'm going to let you guys work on the assignment. I don't feel like we need to do the next problem. I think you can just work on the assignment. Off you. Enjoy it. Have a good time. Yeah.
I won't write your paper, but can I throw it?
Yeah. Here you go. Yes. Oh, yes. Oh, yes. Hey, guys. When you do this, I'm going to make this little dude extra credit. So write extra credit on this guy. And there's 2 missing values. These pyramids right here, see them? See them? They are 36 inches high. Their height is 36 inches. for the pyramids. The cylinder legs are also a height of 36 inches. I think. I did for the cone. And then the height of the cone is 15. The height of the cone is 15. Yeah. Thank you. The person who made it had hand drawn it, and then she typed it. And she left that information when she typed it. But it looked better, so I took the typed version.
The radius of this one is just 12.
Yeah, because it matches, so you don't really need that again. I think that's it. Okay, so this sheet is going to be extra credit. Everyone see that? The Tin Man? No, the Tin Man.
Oh,
This guy right here is extra credit.
okay.